This is Selena and Samantha doing a Calculus Unit 10 bonus question on page 93, number 18. The relative percent of carbon dioxide C in a carbonated soft drink at T minutes can be modeled by the function of Ct equals 100 divided by T, where T is greater than 2. Determine the derivative function of C and interpret the results at 5 minutes, 50 minutes, and 100 minutes. Explain what is happening. So from the question, we get the function Ct equals 100 over T, and it has to be T is greater than 2. And we have to determine the derivative. In order to determine the derivative, we take the quotient rule. It's top prime times the bottom minus bottom prime times the top over bottom squared. The constant rule indicates that 100 becomes 0 times t is still 0, and t prime becomes 1 times 100 is negative 100 over t squared. So our derivative function is negative 100 over t squared. So now we will input the times for 5, 50, and 100 minutes. So for 5, after you input that into the derivative function at t equals 5 minutes, c prime t equals negative 4. At t equals 50 minutes, c prime t equals negative 1 over 25. And at t equals 100 minutes, c prime t equals negative 1 over 100. Now what does this mean? C prime t is the derivative function, which is also the rate of change. So the rate of change in these are negative 4, negative 1 over 25, and negative 1 over 100 respectively to the 5 minutes, 50 minutes, and 100 minutes. These values represent this rate of change and the slope to, approaching the horizontal line, which means as the time is increasing, the amount of carbon dioxide in the carbonated drink is decreasing, and which ultimately means the pop or carbonated soft drink is becoming flat.